is the pre-assessment for multiplying, adding, distributing polynomials. I'm going to see if I can get this done in 30 minutes, less than 30 minutes. I have to be somewhere at 2 o'clock. So here we have monomials times monomials. We are going to always multiply coefficient with coefficient. 5 times 3 is 15. And then when we have like bases, we have x and x, what we do is we add their exponents. So we have x to the 3 plus 2, or 15x to the 5th. So we're going to move through these relatively fast. So coefficient times coefficient is 16. B to the 2nd plus 1. We don't see a 1 there, but there's an invisible 1 there. So this gives us 16b to the 3rd. Coefficient of r to the 4th is 1, so we have 1 times 4, which is 4, and then we have r to the 4th plus 1, which gives us 4r to the 5th. Coefficient times coefficient, 3 times 8 is 24. Like bases, m to the 4th times m to the 3rd is m to the 4 plus 3, 24m to the 7th. 6 times 3 is 18. Like bases, like variables, k to the 1st plus 2, 18k to the 3rd. 2 times 8 is 16. Now this is the first one where we have multiple variables. So we're going to multiply u to the 4th times u to the 4th, which, like bases, we do addition between those two exponents. And then we have v to the 3rd, which doesn't have a partner. So that just gets put here, v to the 3rd. So my answer would be 16u to the 8th, v to the 3rd. Number 7, coefficient times coefficient. 5 times 4 is 20. Now here's the trick one. U doesn't have a partner, so you have u squared. V doesn't have a partner, so that's v to the 4th. Remember that your variables have to be in alphabetical order. U comes before v, but we cannot combine those exponents to make to the 6th. The only time we add exponents is when we have like bases. And these are different bases. The base is u and the base is v. This one is a bit of a trick question. It's a weird one. It's already simplified. We can't do anything else. 8 times 5 is 40. Here's a little trick again. We have our x and our x. That's x to the 3rd plus 1. And then we have y to the 1st and y to the 2nd, which gives us y to the 1 plus 2. So our answer is going to be 40, x to the 4th, y to the 3rd. Alphabetical order. 2 times 8 is 16. A to the 1 plus 2, 16a to the 3rd. 8 times 3 is 24. We have x to the 0 plus 3. Some of you simplified x to the 0 to make 1. That's fine. When you have 8x to the 0, that's 8 times 1, because that's multiplication going on between there. So you could have simplified it, but I like showing that we still have like bases and we add their exponents. And we're adding, not multiplying, so we still get x to the 3rd, 24x to the 3rd. 7 times 3 is 21, b to the 2nd plus 1, 21b to the 3rd. Coefficients are 1 and 1, so we have like bases. We have x to the 1st plus -4, which makes x to the -3. Now, if we paid attention to the directions say contain only positive exponents. So we have to simplify that. No, next one. So we can't leave it with a negative exponent. So we move the base down into the denominator, which changes the sign of the exponent. When you change the sign of the exponent from -3 to +3, you change the location of the base. It's in the numerator. It now goes into the denominator. So very important. That's how we get rid of negative exponents. Change the location. Oh, very similar. This is x to the 1 plus 3, which equals x to the 4th. This is 1 times 4, which is 4. Coefficients first, r to the 1 plus 3, which equals 4 to the r, 4r to the 4th. 6 times 3 is 18. A to the -2 doesn't have a partner. B to the 3 plus 1 gives us 18a to the -2, b to the 4th. Now, the exponent that we can't have a -2, so we have to change the location of the base. The base of that exponent is only a. The exponent for 18 would be an invisible 1 right here, and the exponent of b is 4. So those don't have to be changed. We're okay with having those exponents. So the only thing we have to change the location when we change the sign of the exponent is the base of -2, which is a. So that's going to equal 18b to the 4th over a to the 2nd. 17, we've got 3 coefficients, 2, 8, and 3. 2 times 3 is 6. 6 times 8 is 48. That's going to be my coefficient. I have m to the 4th plus m to the 2nd. And then we have n to the 2nd plus -4, which gives me 48 m to the 6th, n to the -2. I can't have that negative exponent, so I have 48 m to the 6th over n to the 2nd. We have 2 as the only coefficient, m to the 4th plus 4, n to the 1st, no pair, no partner, m to the 8th, n. We have 3 times 1 is 3, a to the 1st plus 3 times b to the 3rd plus 4, which equals 3a to the 4th, b to the 7th. 6 times 8 is 48. Let's do the m alphabetical order, m to the -4, n to the 1 plus 3, 48 m to the -4, n to the 4, and I need to get rid of that negative exponent. So 48 and n stay in the numerator, m goes down in the denominator, and that exponent becomes positive. 4 times 8 is 32. We have x to the 5th plus 5, and we have y to the 5th plus 1. So that gets 32, x to the 10th, y to the 6th. 6 times 2 is 12, x, y to the 2nd. No like bases or variables, so we just rewrite them. 6 times 4 is 24, a to the 3rd, b to the 2nd plus 1, which is 24, a to the 3rd, b to the 3rd. Coefficients are 1 and 3, so we get 3, x to the 1st plus 1, y to the 1st plus -3. That gives me 3x squared, y to the -2. And let's get rid of that negative exponent, 3x squared over y to the 2nd. Coefficients, 3 times 7 is 21, u to the 1 plus 3, v to the 3rd, no pair, partner, 21, u to the 4th, v to the 3rd. Now we are adding likes. I guess I probably should have done this one first. It's very interesting that that came second. Sorry about that. This should have been the first couple of problems. All right, we're adding binomials. When we add, we have to have like terms. Like terms have the same variable. to the same exponent. So they have to have the same variable to the same exponent. Now let's make that a little bit smaller. So same variable, a to the second. So we're looking for an a to the second and an a to the second. So all of these are like terms. When we combine the like terms, we have to combine their coefficients. So 3, that was not, I touched yellow. 3, -5, and +6. So when we combine like terms, we're going to combine their coefficients. They're like terms because they're all a squares. We're going to combine 3, -5, and +6, which gives me 4a squared. And now I've done those terms, and I like using the different colors. It helps me keep track of what I've done and what I haven't done. So we have a to the third this time, so I'm looking for other a to the thirds, a to the thirds. And I'm also looking for their coefficients. So I have -2, I have +3, and +1. So that gives me +2a to the third. +2a to the third. Now I'm moving down the line. My next variable, a to the fourth, a to the fourth, a to the fourth are all like terms. I'm going to combine their coefficients, -5, +8, +8, which gives me, what's that, 11 plus 11a to the fourth. I think that's good. 3, -5 is -2, -2 and +6 is +4, -2, +3 is 1, +1 is 2, -5 and +8 is +3, +8 is +11. Now I need to make sure that my answer is in standard form. So I would rewrite this as this. We have a to the fourth, a to the third, a to the second. The coefficient does not determine standard form. It is the first variable in each term. All of these terms only have one variable, so it's relatively easy to do this at the moment. It will get more complex when there are multiple variables, but we always look at the first variable in the term. And then if it's tied alphabetical, then we go to the exponent and we do the lowest or the first alphabet with the highest exponent. All right, we have 5a to the third, and I'm looking for another a to the third. So I don't see one, so I'm going to write 5a to the third. That term's done. Next one, 5a to the fourth. So I'm looking for a to the fourth, a to the fourth. And so we have +5, -5, and -4. And I'm going to cancel them out. So I'm not going to redo them. We have a to the second. And I have +1, +1, +3, which gives me +5a to the second. My marker's not working so well. And I'm going to cross them out. And now I'm left with 6a and 3a, which gives me +9a. Remember, we combine their coefficients. Now I want to make sure it's in standard form. I look at the first term, that's a. So those all tie. I don't use alphabetical order because they're all the same variable a. So now I have to go to their exponents. So -4a to the fourth plus 5a to the third plus 5a squared plus 9a. Good. That would be my answer. I can't combine them because they're not like terms. They have the same variable, but not to the same exponent. So we again, 5x. I'm looking for x to the first, x to the first. That's it. That's our only pairs. Those combine and cancel, -5 and +5. Now I'm looking at x squares. X squares. I have a -1 and +4. That makes 3x squared. Those are done. And now I have a constant. I have 1 and 1. So that makes 2. Those are done. Now x to the fourth. Here's the pair. That gives me +x to the fourth. We have 4 and -3 makes +1. I don't write 1x to the fourth. Those are done. And then 7x to the third doesn't have a partner. So I know which ones I've completed by doing that cross out. Nothing gets left and I don't duplicate, and that's a nice way of keeping track. Now I'm going to write it in standard form. And I have 1, 2, 3, 4 terms. When I finish and rewrite, I should have 4 terms. X to the fourth, third, second, and that will be my answer. So 6p squared, negative 5p squared, positive 2p squared. So 6 and negative 5 make positive 1 plus 2 gives me 3p squared. Cross them out so I don't redo them. I have a constant, and a constant. So negative 6 and negative 6 is negative 12 plus 2 is negative 10. Very efficient way of doing this. We have p to the third. That's it. So negative 5p to the third. There's no pairing. And then I have negative p and positive 2p, which gives me p. If I see that maybe I made a mistake, I'm still looking at the exponents, the bases and the exponents, to see if there are any like terms. Maybe I didn't combine them. Maybe I missed something. So we can always go back and be cognizant that we can make mistakes. So let's put it in standard form. Plus 3p squared plus p minus 10. That should be the answer. For r, I'm looking for r to the first power. There is no pair. For r, gone. R squared, that's it. So positive 7, positive 4 gives me 11r squared. Those are done. R to the fourth, that's it. Negative 5r to the fourth. Those are done. Constant, negative 3, positive 4 is positive 1. And r to the third, plus r to the third. Now I'm going to write it in standard form. Negative 5r to the fourth, plus r to the third, plus 11r squared, plus 4r, plus 1. Don't be afraid to do the canceling out on that one too. You could cancel in those problems. That wouldn't be the worst. All right, in number 31, now we're simplifying the sum. So we have this group of polynomials plus this group. And we see Chewbacca is here. In order to get rid of Chewbacca, we have to take this, oh, that didn't work out well. We have to take this positive and we have to distribute it into the parentheses to the right of it, because there is a positive 1 that is multiplying the parenthesis on the right. So once we distribute, it also removes the Chewbacca on the left. So this is not affected, so I just rewrite it. And then I distribute that. Positive 1 times 3 is positive 3. Positive 1 times negative 5n squared is negative 5n squared. And positive 1 times 3n is 3n. And now I'm back to this problem. It looks identical to this problem. So we're looking for like terms. We have positive 2, positive 3, which gives me positive 5. They're done. We have positive n squared, negative 5n squared, which is negative 4n squared. Those are done. And then we have negative 4n, positive 3n, which is negative n. Those are done. We can still do the cross out. And now we want to write it in standard form. And that should be the correct answer. So here we just have one initial step where we have to distribute that positive sign into, and we know that anything times 1 keeps it as the same. It doesn't affect. So we have 3 minus 6x squared plus 6x plus 8x to the fourth plus 3 minus 8x. So we have a positive 3 and a negative 3 and a positive 3, which makes 6. Those are done. We have an x squared. That doesn't have a partner. That's done. You have an x to the first and 6x and negative 8x, which makes negative 2x. Those are done. And then you have an 8x to the fourth that doesn't have a pair. And now we write it in standard form. 6x squared minus 2x plus 6. Really important to have a system that you can repeat and replicate, and it ensures accuracy. And that's why Mr. Mac is so big on showing your steps, showing each one, and that helps mitigate the number of mistakes that you can possibly make. And these are silly mistakes. Typically at this stage, if you're systematic and you do enough steps, it should be only silly mistakes that you're making. And we can fix those. A squared, which is 9a squared. Those get canceled out. A to the fourth, 11a to the fourth. So my answer is 11a to the fourth plus 9a squared plus 2. Last two, we're going to distribute. I got 5 minutes. 5n squared plus 2 minus 5n to the fourth plus 3 plus n squared plus 6n to the fourth. 5n squared, n squared, 6n squared, positive 2, positive 3 makes positive 5. Sorry, I forgot to cancel those out. Negative 5n fourth, 6n to the fourth is n to the fourth. So we have n to the fourth plus 6n squared plus 5. We're going to distribute. That's not going to affect the parentheses in front. And multiplying by 1 does not change the values in the second parentheses either. So now we're going to combine like terms. You get 6k to the fourth. Combine like terms, negative 8k. And we have 7 and 4, which is 11. And that's already in standard form. Now when we have a negative this time outside of the parentheses, that will affect it, because we know that that's a negative 1. So when I multiply negative 1 times anything, I'm going to get its inverse or opposite value. So now we got to be very aware. It's still not going to affect the parentheses to the left. So we get 3n minus n to the fourth minus n to the third. This time we're multiplying negative 1 times 2n to the fourth, which makes negative 2n to the fourth. We have negative 1 times 3n to the third, which gives us negative 3n to the third. And negative 1 times 8n, which gives us negative 8n. So all the signs inside will change. We have n to the first, n to the first. We have 3 and negative 8, which makes negative 5n. We have n to the fourth, negative 1 and negative 2, which makes negative 3n to the fourth. We have n to the third, negative 1 and negative 3 makes negative 4n to the third. Let's write them in standard form. So negative 3n to the fourth minus 4n to the third minus 5n. Alrighty. We're distributing this negative into this parentheses. That will change the sign of each of those terms. So 8 minus v to the fourth plus 3v squared minus v squared minus 2v plus 8. We have a positive 8 and a positive 8, which makes 16. We have a negative v to the fourth with no pair. We have v to the second and v to the second, which makes positive 2v to the second. And then we have negative 2v. So let's put it in standard form. Negative v to the fourth plus 2v squared minus 2v plus 16. That was a good one. That was a good one. So we have a negative that we are going to distribute, which will change all the signs of the terms inside that right-handed parentheses. 3 plus a squared minus a cubed minus 2a squared minus 7a to the fourth minus 1. We have a constant and a constant, which makes 2. We have a to the second, a to the second. We have a to the third, which doesn't have a pair. And we have, oh, I didn't cross them out, sorry. And then we have negative 7a to the fourth. So negative 7a to the fourth minus a to the third minus a squared plus 2. 2 more. Distributing, I see I got 1 minute. I'm running out of time for this. 3x plus 7x squared plus 7x to the fourth minus x minus 7 plus 4x squared. Partnered up. Partner 2x. Don't forget to cancel. x squared makes 11x squared. X to the fourth doesn't have a partner, and the constant doesn't have a partner. So that's going to be 7x to the fourth plus 11x squared plus 2x minus 7. And last one that I'm going to do before I splice it, because I got to be somewhere at 2 o'clock. I will come back and finish this up in maybe 30 minutes. 5m to the third is not affected. Everything to the left of that is not affected. It's only the terms to the right that are affected. Now we're going to combine like terms. So we have m to the third, which gives us 2m to the third. We have negative m, positive 4m, which gives me positive 3m. We have negative m to the fourth, negative 8, which gives me negative 9m to the fourth. And let's write it in standard form. Negative 9m to the fourth plus 2m to the third plus 3m. Okay, I will come back in a bit. It took 11 minutes. Actually, less than 11 minutes. Probably took me only 9 minutes. All right, 41. Now, we have a monomial times a binomial. And I always like, what are we distributing and what are we distributing it to? So we're distributing an 8v squared, and we're distributing it to the 2 terms inside the parentheses, v and negative 6. So we can't simplify by combining like terms in the parentheses. So a way of simplification is distributing. So we're distributing. We just got done distributing. We distributed a positive 1, and we distribute a negative 1. So now we actually have a little bit more. So we have 8v squared times v plus 8v squared times negative 6. Now the place that students have to be really careful about, a lot of my students tend to put a negative here because they see a negative here. That sign does not go here. This sign is attached to the 6. So that sign better be attached to the 6 when you show the distribution or the distributive property. So be careful here. This is what it should. We're distributing a positive 8v squared, so we better see a positive 8v squared here. Really keep in mind that this negative is attached to the 6, and it better stay attached to the 6. It's the only thing that makes sense. So now we have 2 monomials times 2 monomials. So 8v squared times 8v is 8v to the third. We're multiplying like bases, so we add their exponents. 2 plus 1 is 3. And now we're going to multiply 8v squared times negative 6. 8 times negative 6 is negative 48, and then we have v squared. So this is my final answer. This cannot be simplified. We can't combine those two because they're not like terms. They do have the same variable, but not to the same exponent. So number 42, we have 3 times 7a plus 3 times 7. 3 times 7a is 21a. 3 times 7 is 21. Number 43, we have 2 times n plus 2 times negative 3. 2n minus 6. That's a horrible 6. Much better. And this is really what distribution should be like. It should be this simple. Seeing the value outside, distributing to each of the terms inside the parentheses. That gives me 20m minus 16. We have 6 times 2x plus 6 times 8. Really important that you always have a sign in between these two monomial products of monomials. I also see students forgetting to put that sign in between the two. So that gives us 12x plus 48. We have 5xy times x plus 5xy times 8y. So now we have a little bit more sophisticated monomial times a monomial. We multiply coefficients. 5 times 1 is 5. Like bases, x times x is x squared, and then the y. We have 5 times 8 is 40. X doesn't have a partner. Y to the first times y to the first is y to the second. Now, some students didn't know, there were a couple situations here with 46. Some students thought that they were like terms. They're not like terms. You look at the first variable in the term. That's x and x. Okay, they're the same. And now we have to look at the exponents. That's x to the second and x to the first. Those are not like, so we can't combine them. And standard form, I'm writing x to the second before x to the first. So these can't be combined, and they are already in standard form. This is proper standard form. So 5x squared y plus 40xy squared would be how you would say it. So 2 times 5u plus 2 times negative 2v, 10u minus 4v. 2x times x plus 2x. Did you see that? I wrote 8. I was looking at 8 and wrote 2. That was interesting. A little subconscious, right? 2x times x gives me 2x squared. 2x times 8y gives me 16xy. Coefficients, then variables. There were no like variables, so we just show them written next to each other, alphabetical order. 5x to the third times x plus 5x to the third times 2y. 5 times 1 is 5. X to the third times x to the first is x to the fourth. We add those exponents. 5 times 2 is 10. X to the third times y is x to the third y. That is in standard form already. 4a times 2a plus 4a times negative 7b. Don't forget that negative. 4a times 2a is 8a squared. 4a times negative 7 is negative 28ab. Ooh, look at this one. Oh yeah. So we have 5m squared n squared times 3m squared plus 5m squared n squared times negative 7mn plus 5m squared n squared times 5n squared. So this is a monomial, one term, a monomial times a trinomial. We have 3 terms, 1, 2, 3. So we'll see those 3 terms, 1 term, 2 terms, 3 terms. And we're multiplying, distributing that outside term to each of the ones inside. So 5 times 3 is 15. M to the second times m to the second is m to the fourth. N squared doesn't have a partner. Remember, those variables need to be in alphabetical order. Now we have 5m squared n squared times negative 7mn. That makes negative 35. Coefficients first. Like variables, m squared times m is m to the third. N squared times n is n to the third. 5 times 5 is 25. We have m squared, no partner. N squared times n squared is n to the fourth. So we look at the first variable in each of the terms. Look at the first variable. M is the first variable. M is the first variable. M is the first variable. These never come into play. The n's never come into play. I don't care what their exponents are. The only thing I'm concerned about is the first variable. This is m to the fourth, m to the third, m to the second. Descending order, so it is in standard form. Number 52, 6xy times 2x squared plus 6xy times negative 8xy plus 6xy times 2y squared. 12x to the third y, negative, what's that, 648, x squared y squared, and 12xy to the third. Look at the first variable, x to the third, x to the second, x to the first. That's in standard form. 3 times 2x squared plus 3 times 5xy plus 3 times y to the second. 6x to the second plus 15xy plus 3y squared. So if we look at the first variable, x, x, y. So these x's are going to come before this y. This y has to be the last one. Now these are tied, so I look at the exponent, x to the second, x to the first. So x to the second is going to come before x to the first. So this is in standard form. We are good to go. One more. So that's in standard form. We like that. 4x squared y to the fourth times 8x squared plus 4x to the second y to the fourth times negative 6xy plus 4x squared y to the fourth times 8y to the second. 4 times 8 is 32. X to the second times x to the second is x to the fourth. Y to the fourth doesn't have a pair. 4 times negative 6 is negative 24. X to the second times x is x to the third. Y to the fourth times y is y to the fifth. 4 times 8 is 32. X to the second doesn't have a pair. Y to the fourth times y to the second is y to the sixth. In standard form, x to the fourth, x to the third, x to the second. My y values and their exponents don't come into play when ordering. They're important, they're part of the term, but we're talking about the order. So 3m times 4m squared plus 3m times negative 5mn plus 3m times negative 4n squared. That's 12m to the third minus 15m squared n minus 12mn squared. Good. All right, now we are multiplying binomials. And I always said that this is, I call it a double distribution. So we're going to take this first term and we're going to distribute it into the other parentheses, to the two terms in the other parentheses. And then we're going to take my second term and we're going to distribute it to each of the terms in the second parentheses. So that's why I say it's a double distribution. We're distributing a 4n and then we're going to distribute a negative 7. So what does that look like? That looks like 4n times 2n plus 4n times 3. That's the first distribution, 4n times 2n, 4n times 3. And then we're going to distribute the negative 7 to both of those terms again. Negative 7 times 2n and negative 7 times 3. And then we just multiply. Multiply the binomials. 4n times 2n gives me 8n squared. 4n times 3 gives me 12n. Negative 7 times 2n gives me negative 14n. And negative 7 times 3 gives me negative 21. Now what's unique in this is that we end up with like terms. 12n and negative 14n can be simplified. So we have to combine those coefficients. And that gives me 8n squared minus 2n minus 21 is my final answer. So we're going to double distribute. And people also call it FOIL. First, outer, inner, last. So the firsts, the outers, the inners, inners, and the lasts. So the first would be these two. First in the binomials, 4x times 5x. The next one would be the outer. The outer are going to be the outside two. So that's plus 4x times 4. The inner would be the inside two, the inside two terms. So that's plus 3 times 5x. Ooh, that didn't work. What happened there? Sorry, I wanted to move those. Oh, I did it again. Stop it. Oh my goodness, I don't even know what I did that time. Is it up here? Yeah. Ay, ay, ay. Let's do that. That looks pretty on spot. Can I move that? Oh man. Mr. Mac has made a mess out of this. Okay. That did not work out well. First, outer, inner, and now we have our lasts, which are the last. Oh, that did not work. That is not aligned. There we go. Now we're aligned. Yep. Last are blue. Those are the last of the terms. Those are the last in the binomials, and that is positive 3 times 4. So FOIL is not as nice as my double distribution, that's for certain. So 4x times 5x is 20x squared. 4x times 4 is 16x. 3 times 5x is 15x. And 3 times 4 is 12. We're going to combine like terms. Our inside and outside, our inside, or outside and inside, outer and inner, are going to be like terms. So we can combine those coefficients. We get 20x squared plus 31x plus 12. I'm going to do the double distribution. 8x times 4x plus 8x times negative 3 plus 6 times 4x plus 6 times negative 3. That is 32x squared minus 24x plus 24x minus 18. What happened to our outside and inside? What happened to our middle two terms? Negative 24x, positive 24x? They canceled. Very interesting one. That's a fun one. That's unique. That doesn't always happen. Let's do the double distribution. We should look at this. 7x minus 8 and 7x plus 8. Anybody remember what we call that? Conjugates. Conjugates. What's going to happen? I don't know if you remember conjugates. Your outside and inside are going to be opposite of each other. And your first and last are going to be perfect squares. So you have 7x times 7x plus 7x times 8 minus 8 times 7x minus 8 times 8. 49x squared plus 56x minus 56x minus 64. Your inside and outsides cancel, your middle two, and you're left with 49x squared minus 64. When you have conjugates, you notice that 49 and 64 are perfect squares. That didn't happen here. Notice that didn't happen, even though the inside and outside canceled, but they did not produce perfect squares. Reason being, these were not conjugates. These were not opposite of each other. So only when we have conjugates do you produce perfect squares, because you're multiplying identical firsts and identical lasts. Ooh, this is a great one. So you have to rewrite this as 4n minus 4 times 4n minus 4. Because when we have 5 squared, remember that equals 5 times 5. Or if you have negative 4 squared, that equals negative 4 times negative 4. So it's identical. So the base of this exponent, here's our exponent, the base of it is that quantity. So we need 2 of those. That's what the 2 represents. So we cannot distribute that 2. It does not become 16n plus 16. That would be incorrect. We're just going to do a double distribution again with these identical ones. These are not conjugates because they're not opposite. This is called a binomial square because we are squaring a binomial. So we get 4n times 4n plus 4n times negative 4 minus 4 times 4n minus 4 times negative 4. That's going to be 16n squared minus 16n minus 16n plus 16. A lot of 16s there. This time my inside and outside are not opposite. They're the same. So you're going to double that value. 16n squared minus 32n plus 16. That's an interesting one. You should do a lot of those examples. 61, we're going to do 8x times 5x plus 8x times 3y plus 4y times 5x plus 4y times 3y. So we notice that now we have 2 variables. We have variables for each of the binomials, each of the terms in the binomials. 8x times 5x is 40x squared. 8x times 3x is 24xy. 4y times 5x is 20xy. Make it xy, not yx, alphabetical order. And 4y times 3y is 12y squared. Notice our outside and inside are like terms, so we can combine those. 24xy and 20xy is 44xy plus 12y squared. Handful more. 8u times 7u plus 8u times 3v minus 3v times 7u minus 3v times positive 3v. 7 times 8 is 56u squared. 8 times 3 is 24uv minus 21uv, alphabetical order, minus 9v squared. 56u squared plus 3uv minus 9v squared. Last one. Last one on this page. M times 8m plus m times 6n minus 4n times 8m minus 4n times 6n. 8m squared plus 6mn minus 32mn minus 24n squared. Oh, that's a good one. 8m squared, positive 6 and negative 32 gives you negative 26mn minus 24n squared. 2 more, I think. 64 and 65. 5x times 4x plus 5x times y plus 4y times 4x plus 4y times y. 20x squared plus 5xy plus 16xy plus 4y squared. 20x squared plus 21xy plus y squared. That is in standard form. X squared, x to the first, no x value in the y squared. And the last, but not least, total of an hour? All right, it took me an hour. So 4x times 5x plus 4x times y minus 6y times 5x minus 6y times y. 20x squared plus 4xy minus 30xy minus 6y squared. 20x squared minus 26xy minus 6y squared. Woo! Okay, that was good. That's the last one. Here's the answer key. You can check your answers. Hopefully, I didn't make any mistakes. Check them out. Have a great day.